Hello everyone, today I am going to discuss some numericals from the chapter Solution. So let us start with the first one. A 5% solution by mass of cane sugar in water has a freezing point of 271 Kelvin. Calculate the freezing point of a 5% glucose in water if the freezing point of pure water is 273.15 Kelvin. 273.15 Kelvin, that is 0 degree. No? So first given, so mass of sucrose is given, no? 5% cane sugar. So mass of cane sugar is given. So moi ya sucrose lekhisu. So you can write here cane sugar. Mass of cane sugar is given. It is 5% solution by mass. That means mass of cane sugar is 5 gram. So if mass of cane sugar is 5 gram, so solute is 5 gram, then the solvent is, solution is 100 gram. Na? So solvent is 95. So mass of water is 95 gram because solvent plus solute, solution. So solution is 100. So mass of solvent 95 gram. Then molar mass of sucrose or cane sugar, it is 342 gram per mole. You can calculate it, 342 gram per mole. Cane sugar or molar mass. And mass of glucose, second part, mass of glucose is given again 5%. So mass of solvent again 95 gram. And molar mass of glucose, it is 180 gram per mole. Okay. Next, so from this given data, we can calculate the molality of sucrose or cane sugar. So molality is number of moles, that is mass by molar mass divided by mass of the solvent in kg. So if it is in gram, so you have to divide it by 1000. Okay, so this is the formula of molality. Now putting the value, so molality of sucrose solution, strength of sucrose or cane sugar solution in molality, it is 0.154 molal. So we can find out depression of freezing point, that is delta TF for sugar solution or cane sugar. Delta TF is equal to TF naught minus TF. So TF naught, that is pure water freezing point, it is given 273.15. So minus, in sugar solution it is also given 271. So minus 271, it is 2.15. So delta TF is given. So if delta TF is given, we can find out KF. So KF value is equal to delta TF by M. Okay. Next, molality. So putting the value, you will get 2.15 divided by 0.154. Now molality of glucose solution. So molality of glucose solution, again mass, it is mass of glucose 5, molar mass 180, 95 gram is water, mass of what solvent water. So in gram, so you just calculate it out and it is 0.292 mole per kg, that is molar. Okay, so delta TF for glucose, delta TF for glucose kiman hobo? Delta TF for glucose is KF into M. Now KF value, it is given, KF value into 2, so KF value, it is already there, into M, so it is 4.08. So freezing point of glucose solution is, so as delta F value is 4.08. So now we can find out the freezing point of glucose solution, that is TF of glucose. It is TF naught minus del TF. So 273.15 minus 4.08, it is 269.07 Kelvin. So this is the value of freezing point of glucose. Okay. So next one, benzoic acid completely dimerizes in benzene. So if benzoic acid completely dimerizes in benzene, that means if we take 1 mole, then we will get half mole. Eta benzoic acid lole ami duta benzoic acid lole 2 benzoic acid combined to give 1. So if we take 1, we'll get half, no? So benzoic acid completely dimerizes in benzene. What will be the vapor pressure of a solution containing 61 gram of benzoic acid, 500 gram of benzene, mass of solute, mass of solvent is given. Vapor pressure of pure benzene at the temperature of experiment, it is 66.6 torr is given. Torr, unit of pressure. What would have been the vapor pressure in the absence of dimerization? First we have to find out the vapor pressure of the solution when benzoic acid completely dimerizes in benzene. So as you know, benzoic acid completely dimerizes in benzene, so we can easily find out the I value, no? And here in the absence of dimerization, that means again we know the I value. So given is mass of solute, it is 61, mass of benzene solvent 500 gram, it is given. Vapor pressure of pure benzene PA0, it is 66.6 torr. So we have to find out the vapor pressure of the solution P. Again we know molar mass of the solute, that is benzoic acid, we can calculate it out. It is 122 gram per mole. Molar mass of the solvent, that is benzene, it is 78 gram per mole. So according to the question, as benzoic acid completely dimerizes in benzene, so I value is equal to half hobo. If you remember, I value, I is equal to number of particles after association divided by number of particles before association. So if we take 2 molecules of benzoic acid, we will get 1 molecule, no? So after association it is 1, before association it is 2. So 50% हो जाए total. 100 टा molecule लले किमान होबो 50. So I value is half. So लिखि लबो पारा I is equal to number of particles before association, after association divided by number of particles before association, or you can directly put I is equal to half. So number of moles of solute, number of moles of solute, we can find out mass of solute divided by molar mass of solute. Number of moles of solvent, it is mass of the solvent divided by molar mass of the solvent, mass of the solvent divided by molar mass of the solvent. So we can find out XB. XB is NB by NA plus NB. So putting the values, evaluate eta put koilo, ami ki palo? Calculate kori 0.5, 6.41 plus 0.5. So this value you see, NA value is greater than NB value. So in the denominator part, generally we neglect this part, na? I mean directly XB type ki likho. For a dilute solution we just write NB by NA. So simple calculation karone you can also neglect this value. Result just point something difference eta ahibo. So moi yat just completely thoisu. So 6.91 and 0.5. So 50 by 691. So again, the value of relative lowering of vapor pressure in the presence of association, when association takes place, it is I into XP, or you can put here I into NB by Na. That means here we just neglect this part. এই পার্টটো নেগলেক্ট কৰি জাস্ট NB by Na আমি লিখিব পাৰোঁ. Okay, so just put the values. 66.6 dot, here it is 66.6 dot, half 50 by 691. So calculate it out. Calculate korle you will get 2.41. So value of P is 66.6 minus 2.41. It will be 64.2 torr. So when association, complete association or complete dimerization takes place, so pressure of the solution is 64.2 torr. Now when association takes place, the value of solution, vapor pressure of the solution is 64.2 torr. Now in the absence of dimerization, is no dimerization takes place, that is I value is 1. So directly we can avoid this I factor. Calculate it, putting the values, calculate it, and we will get the value of P is 61.78 torr. Okay, so now you can try this one. Derive a relation between mole fraction and vapor pressure of the component of an ideal solution in liquid phase and in vapor phase. So in liquid phase and vapor phase, mole fraction and vapor pressure of the component in ideal solution, that was Raoult's law, in liquid phase and in vapor phase. Try to do this. Directly relation is already given, so you try to derive this one. Next one, why is the elevation in boiling point of water different in the following two solutions? So here it is 0.1 molar sodium chloride and next one is 0.1 molar sugar solution. So this is the problem from colligative property. That colligative property is when we dissolve some solute, so colligative property value change hai na. Now colligative property value, we know that colligative property values depend upon the number of the moles of the solute, not on their nature. Okay, now in this case you see this is the 1 mole of sugar. Okay, this is 0.1 mole of sodium chloride. Number of moles is same, but in water sugar does not undergoes any association or dissociation, but in water sodium chloride undergoes dissociation, that is Na plus Cl minus. So Na plus Cl minus, that means number of particles will change. So as number of particles, so colligative property values is applicable only for those solute which does not undergoes any association or dissociation. Then if we take the same mole of solute, irrespective of their nature, then they will show the same colligative properties value. But if solute undergoes association and dissociation, then we will get some abnormal molar masses, due to which colligative property value will change. So here we have to consider this factor, that is dissociation here in case of the electrolyte sodium chloride. So as sodium chloride is an electrolyte, so it dissociates into 2 ions in water. So but sugar is not an electrolyte, so no association or dissociation. So number of particles in sodium chloride is greater than sugar. Molarity is same. Thus elevation is greater in case of NaCl solution. Number of moles increases, so elevation of boiling point, it is a colligative property na? So which only depends on the number of particles. So as we know, so number of particles in sodium chloride increases, so elevation of boiling point also increases as the number of the particle increases. So from here we can say আমি already আগতে কৈছো যে colligative property completely depend on number of particles. So more is the number of particle. If a particular solute undergoes dissociation, number of particle increases, so colligative property value, that is elevation of boiling point, increases. But in case of those solute which does not undergoes any association or dissociation, then number of particles remain same. Okay, so number of particle association dissociation hua nai, so if no association no dissociation, and if we take, remember this one, 0.1 molar sugar and 0.1 molar urea, colligative property value will be same. But as here sodium chloride undergoes dissociation, so number of particle increases, so colligative property value, that is elevation of boiling point, is greater in sodium chloride. Just one mark question. Next one, which of the following solution will have the highest freezing point? Okay, so highest freezing point you have to predict from the given solution. So answer is 1 molar glucose. So you have to just give the reason why. Now as we know, freezing point is depression. When we dissolve a solute, there is a depression in freezing point. So here it will be calcium chloride, CaCl2, not CaCl. So just here typing mistake, CaCl2 hoga. So when we dissolve some solute, then there is a depression in freezing point. Now depression in freezing point, del Tf is equal to Tf naught minus Tf. So Tf2 ki hoga, just Tf is equal to Tf naught minus del Tf. So using this relation, you just predict the correct answer and you can give the reason. Okay, just here you remember CaCl2. Calculate the freezing point. Next one, calculate the freezing point of an aqueous solution containing 10.5 gram of MgBr2 magnesium bromide into 100 gram of water, assuming magnesium bromide is completely dissociated. Okay, so jodi ionic species given thake, if ionic species suppose this electrolyte type is given in water, so it must undergoes dissociation. Salt, etu eta salt, magnesium bromide salt, so salt in water dissociation hobo. Okay, so if I value is not given, I value to here diya nai, so we have to assume that it is completely dissociated in water to calculate out the colligative property related problem. Okay, so here magnesium bromide is completely dissociated, molar mass given, Kf value of water it is given. Now ki diya ase, molar mass of solute, that is 10.5 gram. Mass of solute, molar mass of solute it is 184 gram, mass of solvent 200 gram. Then as it is completely dissociated hole ki hobo, completely dissociated hole we will get Mg2 positive plus 2Br negative. So if in water it dissociate, so ami ki pao NaCl hole Na plus Cl minus, so MgBr2 Mg2 positive plus 2Br negative. Okay, so completely dissociated. So we can calculate out the high value, total number of moles of particle after dissociation, number of particles before dissociation. So dissociation hole kiman particle hobo, magnesium 1 bromide 2, that is 3 divided by 1, it is 3. Okay, now using the relation delta Tf is equal to IKFM. Okay, so IKFM, M is M is your molality. Molality is number of moles divided by mass of the solvent in kg. So number of moles, mass by molecular mass of solute, and if it is mass of solvent in, it is given in gram, so just divided it by 1000. Okay, then we will get putting the value and calculate korle ami value pam delta TF is 1.59 Kelvin. Again we know delta TF is equal to TF naught minus TF. So TF is equal to TF naught minus delta TF. So 273.15 minus 1.59, so value is 271.56 Kelvin. Okay, so next one, here calcium chloride. Okay, determine the amount of mass of calcium chloride, WB, mass of solute, you have to calculate. I value is given here. I value is mentioned, so we have to put it 2.47, not 3. Okay, because calcium chloride dissociated to give calcium 1 2 chloride, no? But I value is given here, so dissolve in 2.5 liter of water such that its osmotic pressure is 0.75 atmosphere at 27 degrees centigrade. So given value, mass of solute you have to calculate. So molar mass of solute, calcium it is 40 and chloride 2 into 35.5, 2 chlorine atoms are there, so value is 111. Volume, it is volume of the solution, it is 2.5 liter. Osmotic pressure pi it is given 0.75 atmosphere. Temperature is given, it is 27 degrees centigrade, so it is 300 Kelvin. So I value is also given 2.47. Again we know the value of R, gas constant 0.0821 liter atmosphere per Kelvin per mole. Now using pi is equal to ICRT. So as dissociation takes place, so abnormality is there. So due to abnormal molar mass, abnormality, colligative property value will change, and we introduce the factor, Van 't Hoff factor. No? So electrolyte, for those solute where the solute undergoes any association and dissociation, we introduce the factor I. And in case of the solute which does not undergoes any association or dissociation, then we directly write pi is equal to CRT. Okay, so pi is equal to CRT. C means concentration in molarity. Concentration in molarity means what? Concentration in molarity means number of moles divided by volume in liter. Number of moles means mass by molar mass, volume in liter, RT already there. Now WB কি হবে? Side just change করলো, MB pi V IRT. So putting the values, value put করা, just calculate it out. It is 3.42 gram. So the amount of calcium chloride dissolved is equal to 3.42 gram. Okay, thank you.